Ryōiki Tenkai. The domain and range of a quadratic function where the coefficient of our x squared is negative. In our previous two discussions pertaining to the domain and range of quadratic function, the coefficients for a are both positive. Here we have this given function where the coefficient is -1. We can rewrite the function as in terms of y, so we could plot it on our Cartesian plane later to illustrate further whether our answers are correct or not. So we could have it like this: y is equal to, you will have negative x squared, you have here minus 2. Again, the coefficient of our x squared is negative, or specifically -1. Now, let's start with the domain. The domain here is a set of all possible values of x that can be substituted here that will give us a real value for our y or our function in general. If we're going to use here, let's say, positive integers like 1, the square of 1 is 1, so we have here negative of that, which is -1 minus 2, -3, that's a real number. If we're going to use here a fraction, let's say 1/2, the square of 1/2 is 1/4. The negative of 1/4 minus 2 is we have -9/4, still a real number. If we're going to use here negative values such as, say for example, -2, but you're still going to square it, the square of -2 is +4, so you will have minus of that, so -4 minus 2, -6, a real number. Even if we have here a rational or irrational number, let's say square root of 2, the square of the square root of 2 is just 2, negative of that minus 2, -4, still a real number. This means that there are no restrictions for any quadratic function, even if the coefficient of x squared is negative, the domain is still the set of all real numbers. In set builder notation, you have set of x such that x is an element of real number. In this way, we can also get a real number for our y or our function. This is always have been the domain of a quadratic function, no matter what it appears or how it looks like, as long as we don't have as long as it's really a quadratic function. Because if this has denominator of this function has denominator with a variable, so it's no longer a quadratic function, right? And if also include here the square root of the variable, it's not also a quadratic function. So as long as it's a quadratic function, regardless of whatever will be the coefficient of our x squared, we have this domain. But for the range, we have a specific process here as well. In our previous examples pertaining on linear function, we tend to actually look into the value of x in terms of y. Okay? We solve for that, and then later on we try to analyze what are the possible values of y that will constitute the range. And other functions as well, we also have specific steps. But for quadratic function, we could learn the range using the concept of the vertex. The vertex is a point on our Cartesian plane in a graph, which is considered to be a parabolic graph, where the graph changes its direction. It is a combination of this. You have -b over 2a. That's for our x value. And for our y value, you have 4ac minus b squared over 4a. Both of this, we have x and y, as long as they are paired, that comprises our point. That point is again the vertex, and we will see later on in our graph that the graph changes direction once we touch this vertex. Now this value here, I would like you to focus this one. This is the value that will tell us the condition of our range. But just for the time being, and for some who might have problems in memorizing this formula, let's try to solve for the value of x first of our vertex, and use that in our function or equation to solve for the corresponding value of y. But what are the a, b, and c coefficients? A is the coefficient of x squared, in this case again -1. B is the coefficient of x. In this case, there's no x term, so it's actually 0. And C is our constant. It's not 2, but it's negative 2. Let's substitute here. Of course, again, you can substitute all three of this here and we'll get a value of y, which again automatically solve the range. But I'm just going to present here the value of x first because we're going to illustrate it in a form of a Cartesian plane later. So you have negative of 0 over 2 times negative 1. No matter what the value of our denominator, our value of our numerator will supersede that. X is 0. So using this value of 0, substitute that on our function, which I think is easier in this case. The square of 0 is 0. Our y value here is negative 2. In short, our vertex is at 0 and negative 2. This is where the graphs change direction. Now going back to this value, this is the value of our y. That is part of our range, y, such that y blank negative 2. I mentioned blank because we still need to complete this with a proper operation or notation. Our notation here would either be greater than or equal or less than or equal. Those are the two things. Because we will still always include negative 2 as it's part of the graph. But the problem now is whether do we include the greater than or do we include the less than? The concern now will be answered by our A. Our A here is a negative value, negative 1. In this case, we will be using values less than or equal to negative 2. If this is positive, just like the two other videos, you might want to check that one. It's greater than here, but in this case, it's less than here. This is now the domain, the range, and this is our domain. Now let's try to come up with a graph of this to illustrate it further and to make some analysis and checking whether our answers for domain and range are both correct. So we can plot it here. Our vertex is at 0 and negative 2. Negative 2 is here. This is our vertex. 0 and negative 2. Our graph for a quadratic function is a parabola. So we need here at least 5 points after the vertex, 2 values of x below and after it. So since it's 0, we can have x here, negative 2, x being negative 1, and on the other side, x being 1, and x is 2. So we will be using these 4 values of x to solve for the other points. Negative 2, the square of negative 2 is positive 4. Negative of 4 minus 2, so y here is negative 6. Next, if it's negative 1, the square of negative 1 is 1. But still have negative 1 here. Negative of 1 minus 2, y is negative 3. If x is 1, the square of 1 is 1, but we have a negative here as well. So that's negative 3, just like for negative 1. And for positive 2, the square of that is 4. We have negative of 4 minus 2. Our y is negative 6. Plotting all these 4 points, here we will have our graph. So you have negative 2 and negative 6. That's a 3, 4, 5, 6. Here's the other point. Then we have negative 1 and negative 3. Here is another point. The other side, 1 and negative 3. We have 2 and negative 6. We need at least 5 points to see the graph because this is not V. This is a little bit curvy here if we're going to include fractions. So the graph will be something like this. If my graph is accurate, pardon. If it's not, it's like that one here and on the other side as well. So as you can see, the graph opens downward now. Okay. Of course, this horizontal axis is our x. The vertical axis is y. Now let's try to analyze this further. Take note that our domain is a set of all possible values of x. We're talking about all the values in horizontal motion. So here, here. Do we allow all these values? As you can see in our graph, this extends further down. This also extends further down. So as long as it goes down without bound, it will increase the value of x here and here, x here as well. It will include all possible values of x. Hence, our result for our domain being the set of x, such as x is the element of real number, is correct. But for our range, we have here all values of y less than or equal to 2. Look at our graph. All the values of y starting from here and going down. So this value of y here also has specific points on our graph. This y here, as this move further, we also have values of y here. With assumption that our graph is correct. But the value of y will not reach this here, because the graph will only open in that direction. This is why our notation for inequality is less than. It's not greater than. This is again mentioned by our, or understood to be correct by our coefficient of a being negative, so it opens downward and will only end up here. This is the highest. The value now for a y is not the lowest, but it's now the highest possible value, but then it goes down again. This means that our set of all possible values of y in vertical motion, being the range, is also correct. We did this for quadratic function. The domain is still the same, but the range now will depend on the y value of our vertex, at the same time the sign of our a coefficient, and will be understood further by this graph. For the next functions, please do not forget to like this video, share this, comment down, and subscribe to our channel. This is for us to expand our domain further.